In this video, we will go over the test for divergence. It's also called the nth term test. And if the limit of n approaches infinity of a sub n and it does not equal 0 or it's dne, then the infinite series will diverge. But this test doesn't tell us anything if the limit of n approaches infinity. If it's simply 0, it will be inconclusive. We don't know if it will converge or diverge. We'll have to use another test. Another case could be, if you have -1 raised to n where it oscillates. But if b sub n does not equal 0, then the series will also diverge. And you can kind of think about this. If you have parentheses -1 raised to n, it will oscillate between -1 and +1. Infinity is neither even nor odd, and so we won't know if the final sum will be -1 or 1. It will be D&E, and so it diverges. And so here is two problems. We want to determine if the following series diverge or is inconclusive using the test for divergence. And so if you want, you can pause the video here and attempt these two problems. Okay, so for the first one, we could say that the limit of n approaches infinity for 3 over n would be 0. Simply, you can kind of think if n is infinity, you get 3 over infinity, or 3 over a very big number, and you would get 0. And so this would be inconclusive by the test for divergence, and in later videos, we will go over another method where we can easily solve this problem. So this is the second problem. We can first say that the limit of n approaches infinity for 3n plus 4 divided by n plus 3. What I would do is divide each term by n. I can do that if I do it on each side. So I divide this by n, divide this by n, divide this by n, and divide this by n. And then we would get 3 plus 4 divided by n, and divided by 1 plus 3 divided by n. And so we would get 3 plus 0 divided by 1 plus 0, because again, 4 divided by like infinity or a very big number would give us 0. And so here we would get 3, and 3 does not equal 0. So the conclusion that we can make is that this series will diverge by the test for divergence.